Problem 2 from the homework. Two parallel 40 Newton forces are applied to a lever as shown. Let's determine the moment of the couple formed by these two forces by three different methodologies. First one, by the resolving each force into horizontal and vertical components and adding the moments of the resulting couples. By using the perpendicular distances between the two forces and by assuming the moments of the two forces about point A. So for the first one, it's actually pretty much the same as we did in the first one, in the first problem. So we're just going to divide this force into two forces. One that's going to be vertical, force Y, and one that's going to be horizontal, force X. Now, since these two forces are equal, that means this one can be divided into the same two sets of forces. One force X that goes to the left, one force Y that goes down. That's how we create two couples. Couple of vertical forces, couple of horizontal forces. Now, we will not use the full distance of 270 millimeters that we got in here that goes from B to C. Instead, we're going to work with a rectangle triangle formed by these sections. That rectangle triangle will actually look like that. Now, we know this angle right here is going to be 55 degrees. We know the distance from the point B to the point C is going to be 270 millimeters, which we actually can convert to 0.27 meters. If that's the case, we can calculate what's going to be the distance y and the distance x. It's pretty much the same process as we did before for the first problem. So now the angle is actually about the horizontal. So distance y is going to be the full distance, 0.27 meters times sine of 55 degrees. Distance x, it's actually going to be 0.27 meters times cosine of 55 degrees. We will obtain that the distance y equals to 0.2021 meters, and distance x is going to be 0.154 meters. We already have the distances. Now we know the forces going to be, once we decompose them, applied in here, force y, force x, and in here, force y, force x. That means that the moment of the couple can be divided into moment of the couple 1 plus moment of the couple 2, and that moment of the couple 1 can be distance x times force y. Moment of the couple 2 can be distance y, force x from here. So we need to find what's going to be the value for force y and force x. We got a 20 degrees inclination and we got a 40 newtons magnitude of the force. These 20 degrees is actually about the horizontal, so to divide it into fx and fy, we can just use the conventional sine for the y and cosine for the x component. That means we'll have 40 newtons sine of 20 degrees for the component in y, and we'll have 40 newtons cosine of 20 degrees for the component in x. For the component in Y, we'll have 13.68 newtons, and the component in X, it's gonna be 37.58 newtons. That means if we want to calculate the moment of the couple, we just replace the values in these equations. Let me just try to move this a little bit to the left, like this. Just place them in here to do the same. We'll have like that. And I can take this up. This one right here goes this way. And we can just start replacing the values. For the moment of the couple wall, dx, and dx is 0.154 meters times force y, and force y 13.68 newtons. For the moment of the couple 2, we'll have dy, which is 0.221 meters times force x, that's 37.58 newtons. The result, moment of the couple 1, it's going to be 2.106 newtons meters. Moment of the couple 2, it's going to be minus 8.305 newtons meters. How to see if they are going to be minus or positive? Okay, for the forces in X, horizontal, the one in the upper section goes to the right, the one in the lower section goes to the left. That means the rotation will be kind of like this. Count this clockwise, that means we're going to have it negative. That means they go like that. For the forces in Y, they are vertical. The force of the right it's going up. The force in the left it's going down. That means the rotation will look like this, positive. If we add them together, that means moment of the couple 2.106 minus 8.305 newtons meters. We'll obtain a total moment of the couple of 6.1982 clockwise negative. We will use this for the other parts of the problem.